Hi guys. So I am going to talk about naming, and I'm going to divide this into several different videos. So this is the first one that I'm going to be doing. It's over chemical formulas, specifically on ionic compounds. All ions except for hydrogen. Hydrogen is actually going to be put into naming of acids later in chapter 6. So positive ions, otherwise known as cations, are those things that are positively charged. So they can be monoatomic, which is sodium, here where you see only one atom, or it can be polyatomic, which you can see that nitrogen and 4 atoms of hydrogen. So it can be either one of these. And negative ions, known as anions, can be, these guys are going to be non-metal, where the positive cations are metal, and they can be monoatomic as well, such as this chlorine, or you can see where it be polyatomic. You can see in this first one here, it has the sulfur and oxygen combinations, 1 sulfur, 4 oxygens, or here where it is nitrogen and 3 oxygens. So keep that in mind. And when we're writing these guys out, what essentially we are doing is the formula that you have is going to equal 0. So you look at the number of positive charges and you're going to essentially put together the right number so that you can equal a net 0 charge. So for instance, if you're looking here and you want to write a formula that has calcium and chloride together, you're going to see calcium has +2, chloride has this -1. So for this to be equal to 0, you are going to need essentially 1 calcium, right, and 2 chlorines. And so if you write this out, you will see the formula is actually CaCl2, right? And this will end up being the best formula because it essentially has positive charges. So let's go through this so that we can basically talk about and learn how to write these down. So on here, again, these are binary ionic compounds. So we're going to have 2 basically words associated with it. And this is going to be representative metals type, and this is our type 1. So if you look in here, you can see our representative metals are these guys that are in the yellow color here. Not these. These are transition metals, and these guys down here are radioactive elements. So just these guys that are in yellow are the ones that we are going to focus on when we're talking about these representative metals. So I'm going to go and pull up our interactive, and I'm going to go down here, make this a little bit smaller here, make this a little bit smaller, and we're going to go and use this to go through our stuff here. So let's start with just getting the ions. Let's write formulas in the following citation. So if we're just looking at barium ion, you can look here, right? And this is barium. If you remember, you can go through and go 1, 2, 3, 4, 5, 6, 7, and 8 at the top. This interactive one doesn't have it. It's cut off time, kind of towards the top. So if we look here, right, we'll notice that here, it's going to have these 2 electrons that are in its outer shell. Because we want it to be stable, it's going to give those away. So we're going to get this barium that's here, and it's going to be 2+, because we have the 2 basically on here for our valence electrons, and we want it to be stable. So it's going to get rid of those 2 to end up going and being the stable Xeon in forms of electron configuration. So that's what we have there. For the next one over, we're going to look for aluminum. And if you go over here, right, we're going to have this. So aluminum has a valence electrons of 3. So in order for us to be stable, we're going to go back and get rid of those 3, which would be similar to what the neon looks like. So when we write this, you're going to have the 3 positive here. You can look into your periodic table chapter as well, and this will tell you basically what type of cations that these guys most commonly make. So the next one we're going to look at is potassium, and potassium is right over here. And so on here you can see this has the valence electron of 1. So to get rid of that, to be the stable argon, you're going to do the plus. And the last one that we're going to do is, oops, sorry about that. So let me write this again. And then this. The last one we're going to do is radium, which is down here, right? And basically you can see that is in the 2. And so basically what happens here is it's going to lose the 2 to get here to the nice stable radon. And so that's going to make it the +2. So that's how we figure out the ions. We look at how many valence electrons they have. And if you remember, the common rule that we use is the octet rule, 8. There are some slight differences, but that is what we're going to use here. And then essentially get down to where it is stable, right? And so those are the natural ions that they make. Now, if we're looking at anions, we're a little bit, instead of basically getting rid of electrons, we are going to add them. So the very first one that we're going to look at is bromine, which is here. So these are going to be metals. And if you look over here, all of these are going to be nonmetals. So if we look at bromine, in order for it's going to have 7 valence electrons, right? So for it to be stable, we get 1 more. So that's going to make this guy Br negative. Now for nitride, and I'm going to talk about the naming here, we're going to be looking at the nitrogen. And we see that's 5. In order for it to be stable, 1, 2, we need to add 3 electrons. So this is going to be N, 3, negative. Iodide is going to be iodine, which is here. For it to be stable, you need 1. So then we're going to go through here and it's +1. Oxide is oxygen, and we need to add 2. And sulfur is underneath it, right? So it's the same idea. You add 2. So that's how we come up with the ions, or the formulas for the ions. Let's move to actually naming things. So you noticed when we got to the actual anions, you saw "ide" at the end of them. So basically, the first note that we want to do when we name these guys is metal is always first, and the name is unchanged. The non-metal comes second, and the ending of the non-metal is dropped, and we put IDE is added. Just realize that these names do not indicate how many of each ion are actually in the formula. So if we look here, we'll notice that we have sodium at the front and this fluorine. And so basically this is sodium fluoride. For the next one, Sr is strontium, I is iodine, So here we have strontium iodide. Realize that at the end we're using the IDE. For this next one, you'll notice that you have K, so that's here, which is potassium, and we're here, which is oxygen, so we're going to have potassium oxide. Ba is barium, N is nitrogen, so it's going to be barium nitride. Again, notice the IDEs at the end. MgS, so here's the Mg, which is magnesium, and the S is sulfur, so magnesium, what? Sulfide. The end. This, you look, Ca is calcium, then the end again is nitrogen, so you're going to put calcium, that's right, nitride. Al is here, which is aluminum, and O is oxygen, so it's a aluminum oxide. And this last one here, Na, which is here sodium, and P is phosphorus over here. So you're going to have sodium phosphide. So if you notice, the metal is always at the beginning of the name, and the nonmetal is at the end, and you drop the later part of the name and then put "ide." We're going to move on here and do the last part of this, which is given the formula for the following compounds. Refer to the periodic table only. So let me move this up and get to this. And I'm going to leave some spot underneath it so that we can look at it. So we're going to look at cesium, which is here. And remember, we want to do our top again, right? 3, 4, 5, 6, 7, 8. So if we want to write off to the side, we can go this. Okay, if we were putting this by itself, this would be +1, right? Because it would be going to this one. Phosphide is the phosphorus here, right? So then we could go and it would be 1, 2, 3. So this guy right here actually 3 negative. So what would we have to do to get these to be equal? We would need 3 of these, right? So we put CS3P. That's what I would suggest you do as you go through these. Because if you do it step by step like that, it makes it much easier. So let's do calcium iodide. So we go through here, we find calcium, and we write here, and that would take 2 of those, right? And then iodide is over here, which is 1, right? So how many of what do we need to get them to be equal? Wouldn't we need times 2 of these? So then you'd write calcium iodide with 2. Let's go to barium fluoride. Barium is here. Fluoride is that one is up here, right? So we look and we realize that we need 2 of these, right? So we'd write BAF2. And the number is always that superscript, or I mean the subscript there. Sorry about that. Super is above, subscript is below. So that subscript tells us the number of ions we need. The superscript that we write up on top is telling us what the charge is, right? So make sure not to get that mixed up. So magnesium here, again, it's on that second. So to get it to be stable, we need to lose 1, 2 to get over here. And then the nitrogen is here. So that's 1, 2, 3. This becomes weird, right? Because here you have +2, here you have -3. So in order for this to be, you have to change both. This is different than we've been doing, right? This, we need to think of what's the lowest number that both of these can go into. And you might be telling yourself 6. Hopefully that's what you're saying. So these both, if they equal 6, will be the same. So for magnesium, how many of these do we need 2 times what to equal 6? 3, right? For the nitrogen, we need what times 3 times what to equal 6? 2. So when we write this, it's magnesium, 3, nitrogen, 2. Don't make this harder than what it is. It's really not that bad if you take it step by step like this. And that's what I tend to do with all my chemistry stuff, is I like to take it step by step by step so I can figure out what I am doing. So aluminum is here. And if you look, the number of valence electrons we have are 3. So to get stable, we need to lose those. So we're going to have aluminum, 3+, right? And then if we go over here with bromine, we need to just do 1 over add 1 to get our valence stable. So that's -1, right? So how many of these do we need? Well, there's 3 charges here, 1 charge is here. So we're going to say times 3 for the bromine. So then we have aluminum. Bromide would be 3. And our last here, sodium. Let me see, we have sodium over here, which to get rid of is +1. Selenium. So sodium selenide here. So to make this, we go 1, 2, which are 2 negative charges, right? So how many do we need to be equal? We would do this twice, right? So sodium would be first with the 2, and selenide would be by itself. So this is how we do these type 1 representatives metals. And if you remember again, they're going to be these guys that we talk about that are essentially mostly I'm going to be asking about stuff that's in here or stuff that is kind of over in this area over here, right? When it comes to metals. So I hope that helped with the first one, and you can watch video 2 to learn about the type 2 metals, which are transitional metals. Thank you guys. Have a good one.